have principally two types of regression. We have the simple linear regression and we have the multiple. In fact, we have the linear regression, we have multiple regression. Even though the multiple regression can be linear, we also have other types of regression. But what we are going to do right now for you is simple linear regression. We call it simple linear regression because it has to do with only one variable. So we have the simple linear regression model is going to be given as y is equal to, let me use this, plus e, and I'm going to explain the parameters of that linear regression model. Y you see there is called a response variable. There are two variables involved, sorry. Y is a response variable and it depends on what we call the regression variable. But I would like to reduce it to your level. I would like to reduce it to your level. We call it simple linear regression because Y depends only on X. One variable, it depends only on one variable. Are you okay? It depends only on one variable. The one variable is X. Because of that, Y is called a dependent variable. And X is called the independent variable. And what does it mean to say that one is dependent and one is independent? Y depends on X. If X increases, Y will do what? If X decreases, Y will do what? Simple linear regression models a lot of things you find out there. Statistically, we use a linear regression model to represent a number of things. For instance, you came to school this morning, did you not? Some of you came to school and entered the bus. If you were here 2 years ago, that same distance you covered from where you live to here, the price would have been very small. Are you okay? But now it is because of what? Can somebody predict why the price of transportation now rises? It's because of what? Fuel. Which means that the cost of your fare from where you come from to this particular place depends on the fuel. Abi? So which one now becomes the dependent variable? Which one is the independent variable? So what we call the dependent variable now is the cost of transportation. Abi? And it depends on what? Yes, the fuel consumption. You know, when fuel was very simple, that's why we say when the price of fuel reduces, what will be the corresponding value of the cost of transportation? It will correspondingly come low, Abi? Yes, sir. But when the price of fuel rises up, what happens? The price of transportation also increases. There are many things out there we can use. You can go to the market today to buy yams. Abi? Yes, sir. As you go there, you will see that the price of yams depends on the quantity in the market. The price of yams depends on what? The quantity. You cannot buy 2 yams the way you only buy 1 yam. You can't buy 5 yams at the cost you buy 1 yam. Abi? So the price of yams in the market depends on how many. When we talk about quantity, we talk about many things, including the number and also including the size. Again, the price of yam in the market also depends on what we call availability in the market. If you go there, the yams are not available. The little ones you see there, they will be very costly. Because the person will capitalize on the fact that I am the only one who is selling. Are you okay? Yes, sir. I am the only one who is selling. If he does not buy here, he will not see anywhere to buy yams again. And he will now raise his, the price of his yams. And because he knows that you will have to buy it. So, Y is called a dependent variable. Another name for it is response variable. It is the response variable. Another name for the dependent variable is what? The response Another name for the independent variable in terms of regression is called the regressor variable. Regressor variable. We're going to look at simple linear regression in two ways. Number one, we're going to look at the algebraic method. And then the other one, we'll call it scatter plot. We'll look at the scatter plot, the algebraic method, and the scatter plot. Some of these ones we are going to better explain them using examples. In the scatter plot tells us, now let me formally define simple linear regression. Simple linear regression is defined as the relationship between two variables expressed in mathematical form. It is called linear in the sense that it represents a straight line. If you look at what I've drawn on the board, you will see a straight line that cuts across the y-axis in a plane. A straight line that cuts across the y-axis in a plane. The distance from where the line cuts the y-axis from what we call the origin is called the intercept. The distance there is called what? The intercept. From where we have the intercept, we can cut we have a triangle called a right angle triangle. What does it symbolize? If you check here, you have a line that is parallel to the x-axis. We have a line that is also parallel to what? The y-axis. The two of them, the two lines are perpendicular, meaning that they meet at the point at the right angle. Right angle, remember, is 90 degrees. It forms a right angle triangle there. That the distance from where we have to this point where the two lines meet is called the slope. Now let's represent what we have here with this. Now the slope here A and the intercept A and the slope are called the parameters of this model. Those are the parameters we shall estimate to be able to fit a linear regression model. We're going to we estimate the parameters A and B to be able to fit the linear regression model. Remember we said that in this linear regression model, Y is called what? The dependent variable, and X is what? The value of A and B, in fact A and B, they call them the parameters of what? The simple linear regression model. Even though they are parameters of the simple linear regression model, A here stands for what? The intercept. While B here stands for what? The slope. Yes. A stands for the slope. Which one have we not explained? Is E, is it not? Yes. E is called the random error. Yes. E is called the error. E is called the error. Now let me take you a little to why that error must be there. And take you to normal situations in life where there is nothing you do without error, and you must certainly account for it. Are you okay? Are you a molder? A molder. You mold blocks, and you think that you have molded the first block and you are molding the second block, and you think that the first block and the second block are equal in weight. Go and mold again and compare the weight of the two. They will not be the same. What accounts for the difference is the error. Everything we do in life, there must be what? Error. Sometimes you go in your secondary school, you were taught physics. They confine you to a kind of room that they lock every window. How do you ever remember why they say lock every window? They want to do an experiment, carry out an experiment. It's a simple pendulum. Have you ever done that? How many of you did that in your Sunday school days? How many of you did not do physics? It's a simple pendulum. And they say close all windows. Have they ever told you like that? If they have not told you, remember today. They say close all windows. Why are they doing so? Because if you do not close the windows, it is expected that breeze that will come from outside will affect your experiment. Are you okay? Yes, sir. And they say do not do this, do not do that, do not do that. At the end of the day, you have carried out the experiment with all these things intact. You are looking for acceleration due to gravity that is going to give you g is equal to what? 9.8 meters per second, which is always approximated to what? 10 meters per second. You will never get it. You have closed all windows, you do all the things they ask you to do, you perform the experiment very well, you will never get 9.8. Why is it so? And in reporting your experiment, you will say within the limit of experimental error. Within the limit of it. I'm bringing you back to something that you were using and you didn't know why you were using it. Within the limit of what? Experimental error. Where is the experimental error coming from? So no matter what you do, there must be what? Error. There must be error. So here in this model, the error is used to check whatever we're going to do here. So like I said, we are going to look at this simple linear regression in two methods. Number one is scatter plot. Let me start from the scatter plot. The scatter plot is always a diagram. Assuming we have, let me say, y and x, and we have we have that. And we say we have to represent this information in the plot. We have to plot the values of y and 1, or y against x. We are going to get a graph. That graph we shall draw here, we have obtained is what is called a scatter plot. So we'll draw something like this. I think this is the origin. Let's believe that we have y is 1, 2, 3. I mean the x is 1, 3, 4, 5, 6, 7, 8, 9, and it goes like that. That's x. And we have y as 1. I'm trying to bring out that is k. Unfortunately, the board does not have what we call a graph is not graduated. Okay? So, as you are going to draw this is going to be a sketch, but in normal situation, you are supposed to use a graph sheet. So, we have maybe 3, 4, 5, 6, 7, 8, 9, and so forth. Remember, this is y. Now, it means that you presented this information in this graph. When x is 4, what's the value of y? It means you go to where we have x is 4, trace into where we have 2. Where do we have 2? They will meet at this point. I mean, yes, they will meet at this point. At this point, these lines are not necessary. I'm using that to be able to put the point at the right point. The next one is what? When this is 9, y is what? 3. You have 3 here. The two of them meet at this point. When x is 2, what's the value of y? 5. It means we have something somewhere here, and and the mixed there. When x is what again? What's the value of y? So we have 7 somewhere here. The bit at this point. When x is what again? 1. What's the value of y? You see the bit at these points. This should be. Now if you check the board, you would have seen that we have presented all the points. All the points there. This is called a scatter plot. It is a graph that represents the value of y at different values of what? X. That is a scatter plot. But this is one way of representing. If the plots, the points, when I call plots, I'm talking about the points in there, were to be close to a straight line. We use a straight line to be able to determine what we call the line of best fit. We have to draw a line of best fit to determine the relationship between what? Y and x. We have to do that to determine the relationship between y and x. If the relationship is such that the points are so scattered apart, is that relationship close? If the relationship is such that the points are closely related, then for this aspect will be explained more when we are talking about correlation. Are you okay? Correlation. Correlation is the degree of relationship. You measure the degree of the extent to which these values are related. But we are not talking about correlation now. There are two aspects here. We're saying that while regression measures what? The relationship between two variables in mathematical form. Correlation does what? Measures the extent to which these two variables are related. How close are they related? How distant apart are they related? When we get to that one, I will give you many more examples when we talk about your mother having a child or another child from the same mother, from the same father, and your mother having a child from a different father. Who is closer among the two brothers of yours? The same mother gives birth to two of you, but he gives birth to two of you of the same father, and he gives birth to two of you. You are of a different father, the other man is of a different father. Between the two relationships, which one is closer? They want to be the same parentage. I mean, that's by the way. We'll come to that. So this is what we call a scattered diagram. We use what we call line of best fit to be able to represent this information. This one will not explain more about, will not explain detailedly about here. We will talk about the second method of analyzing the linear regression between two variables. And that second method is what? By the algebraic method. Are you okay? In the algebraic method, we are going to find the estimates of the parameters of that model. Which one are the parameters we had mentioned earlier? And somebody mentioned it. The linear regression model is still here. We have told you that y here is what? The dependent variable, also called the response variable. We have told you that x is what? The independent, also called the regressor variable. And we have said that we have A and B, and we call this A and B what? We call them what? What do we call them? Parameters of the regression model. Is it not? Y A stands for intercept, B stands for what? Slope. These two of them, the parameters of the regression model are the ones we are going to estimate. We have to find the estimate of this linear regression model by method of what? Least squares. Take note of that. So this is the time you will be very careful, pay more attention, understand, and ask questions when necessary, when you do not understand. Are you okay? Because I believe that before you leave this class, you should understand every bit of what I say. If I'm too fast, you let me know. Do you know, before now, they say there is what we call, in the secondary school, they say make something a the subject of formula. Have you heard something like that? Yes. We're going to make E here the subject of formula in this model. Let's call this model 1. Equation 1. V. So we are going to make E the subject of formula in make E the subject of formula in equation 1. Make E the subject of formula. How do we make E the subject of formula? Every other thing in the side of E will move to the other side. Abi? Yes. We are also told that if E will stand alone as the subject of formula, A will leave to the other side to become minus A. Abi? So we have it will meet Y already sitting there as what? Minus A. Dx is positive. It is plus here. Abi? Yes, as it crosses the sign of equality, become what? Minus Bx. So that will make E now the subject of formula. Why we are making E the subject of formula? The reason is that we are going to form what we call the sum of squares. Sum of squares for the error. Take note of that. We say we want to form the sum of squares for what? Right. I want you to write the statement here so that we want to form the sum of squares for what? The error. Yes. If we form, what do you call sum of squares? If we square the right hand side, we also square what? The left hand side. Which means that we have y is equal to y minus we have this. But if we say we need to form the sum of squares, it means we sum this, we also sum this. So what we have on the board is called the sum of squares for the error. First, we make the right hand side and the left hand side raised to power 2. We square them, we square both sides. We square both sides and sum them together. It becomes the sum of squares for the error. The next step in trying to find the estimate of the regression model by the method of least squares. Is to find the partial derivative of that sum of squares, the error sum of squares, with respect to the intercept, and next with respect to what? The slope. We're going to do that with respect to, we'll find the partials. What I mean by partial is partial derivative. So that we'll find the partials with respect to WRT, with respect to A and what? Respect to A and B. With respect to A and B. With respect to A and B. In trying to find the partial, what we are saying is that we're going to have, can we call some of this? I can call it anything. Let me call this Q. Are you okay? Q represents this one, that's by definition. I can use any other letter. I can use S, I can use B, I can use whatever. But Q here stands for what? Sum of squares for the error. So that if I want to find the partial, I don't need to be writing sum and all this. So I will now say Q with respect to what? A. Remember we say we take the partial with respect to A, we also take the partial with respect to. When we take the partial with respect to A, we are expected to find the partial of the left hand side with respect to A. Are you listening? I will be very slow here so that you understand. Since you have not been taught the differentiation before. I would have, let me give you two ways. One way is very fast, the other way we are going to derive it. The shorter way is like this. You see that there is a 2 here. Are you listening? Yes. This is raised to power what? whatever partial you are going to take here with respect to A and this, we must first of all take it. Let me give you a small thing about differentiation. If y is equal to ax squared, ax raised to the power what? N. Y is equal to what? Ax raised to the power what? N. And y depends on what? X. The derivative of y with respect to what? X. Derivative of y with respect to x will be, you see this n? I think this n represents 2 here. Yes. We'll take the n first. A is also a constant here. We'll write it here. If the constant is 1, then there is nothing here. Are you okay? The A there is the constant, which we call the coefficient of x squared. The coefficient of x squared. The coefficient of x squared, A can be 1 and A can be greater than what? There are two things there. A can be 1 and A can be what? Now if A is greater than 1, it means there will be nothing here. It means there will be no A here. I mean, so we take this one. What is now here is that you have brought down your n. The n will now be, will no longer be complete by 1. The n will be short by what? What does it mean to say that n becomes short by 1? We will now have what we call n minus, are you okay? If that n is 2, what do you think it will be? It will be 2 into 2 minus 1, is it not? If that n is 3, it will be 3 into x, 3x raised to the power what? Whatever is here is here. The difference is that this one becomes short by 1. Meaning that we have 3 raised to the power x squared. I mean, meaning that we have 2 raised to the power what? X raised to the power 1. I mean, what about here? So, if we check here, the differential of a constant is what? The differential of a constant is what? Okay, you don't know about that. If you differentiate the constant, it becomes what? 0. Okay? The differential of the constant where there is no x is what? 0. So we are going to differentiate the partials of A. These things, there are 2 of them. So we are going to take 2 here. Are you listening? I think we are going to write the 2 here, just like we have written. So we will now have 2 sum of y minus A minus bx. But this time around is 2 minus 1. I think we say so. And 2 minus 1 is now if we continue with this where there is an A here, which is the coefficient, it means that A will be here. But the other thing remains the same. Meaning that as we are going to differentiate, that we are going to find the partial of Q with respect to what? B this time around. You are going to do it 2 times. You are going to take the partial with respect to A. We are going to take the partial with respect to what? B. Now, the partial with respect to B would have been 2 sum of what? The coefficient of B here is what? So you see the x there, and we represent the y minus A minus bx raised to the power 2 minus 1. We have the same thing there. But remember, 2 minus 1 is 1, is it not? And any number raised to the power 1, we don't need to reflect that 1. Are you okay? 2 raised to the power 1 is the same thing as 2. 3 raised to the power 1 is the same thing as what? 3. Even this book raised to the power 1 is that book. Are you okay? Any number raised to the power 1 is the same number. So here, 2 minus 1 is 1. We will not express it that way. That's why I have to claim. But remember that what is there is now 1. Meaning we have the 2 minus 1. There are 2 equations we now have. They call them the normal equations. We have equation A and we have equation what? B. We call them the normal equation. Those equations we are going to do, we are going to equate them to 0. If equal to 0. So they are equations, the two of them are called normal equations. The moment you finish with the partial differentiation, you have to equate them to 0. They now become what we call normal equations. Those are the normal equations we are going to use now to determine the values of A and what? B. We are going to determine the values of A and B in this. I can write this out. I hope you are written. Yes. Or I have to go back again. Yes, okay. We are going to find the values of A and B. What's the first equation and the second equation? What's the difference? Have you seen any difference there? Let me if you see any one difference. Can somebody spot one difference they are saying? The presence of x here. If we divide through by 2 in the both equations, what are we going to get? We are going to now get, we will divide through by 2 and simplify the two equations. You divide through by 2 and simplify the two normal equations. They will become this one. Okay, give me small time. Let me explain first before you write. I will not wipe this time around. Are you okay? Because you want to follow it. We are going to divide these two normal equations A and B by 2. If you divide A, this one is gone. Because if you divide here, you are going to divide the left hand side. 0 divided by 2 is what? 0, is it not? 0 divided by 2 is 0. What about 2 divided by 0? Is it possible? Bring out your calculator if you have and then test. 0 divided by 2 is going to be 0. 2 divided by 0 is not going to be possible. Are you okay? Here we are going to divide the two normal equations by 2 and simplify. If you divide by 2, that one is gone. Now, where I say you should pay attention for the simplification is this. We are summing. See, this sum, as we open this bracket, we are going to have what we call sum of what? Minus what? Sum of A. Minus what? B sum of what? X. B equal to what? 0. We are going to sum all of this. As we sum all of this, what about this sum? Now A is a constant. A is a what? Constant. As you sum them, how many A's are you summing? If you sum A 3 times, it becomes 3A. If you sum A 4 times, it becomes how many A? 4A. If you sum it 9 times, it becomes how many A? 9. If you sum it n times, it becomes how many A? It becomes n times. So we will now have to go, we are summing it n different times. N is any number at all. If we decide to talk our n, we decide to say n is 2, we will make it 2. If we say n is 4, we make it 4. N is whichever number. So summing this one becomes sum of y minus na minus d, sum of x. So I can now, after this explanation, make it to become what? Now the second one is this. Where is the second one? The second one says sum x what? So we have sum x y minus what? Sum a sum of x. Are you okay? Yes, sir. Yes. What about here? Minus b sum what? Is it only x? There is an x here and there is an x here. I mean, yes, now it becomes what? X raised to the power 2. So we're going to further simplify and take everything that relates to y to one side. We'll take everything that relates y to what? One side. We're going to take all the things that relate to x one side and all the things that does not have any x relate to y one side and take all other ones that do not have any bearing with y one side. Are you okay? In this, let me call this one A or A star and call this one what? B star. Now, as of which one? This is the only one that we are going to keep one side. These other ones, they know why they will keep their one side. I mean, again, look at it. So we are going to make anything that has to do with y stand. So in that case, we have said that minus NA or AN. Let me put it this way first. Because A comes before N. As we are carrying it to the left hand side, remember what it becomes of it? It becomes change to what? Plus. It becomes change to plus. It becomes change to plus. What about this side? As it goes the other way, it also becomes change to what? Plus. So we now have AN plus what? B sum of x is equal to what? Sum of y. And we also have A sum of x plus B sum of x squared is equal to sum x y. We have two equations we are going to solve them simultaneously. The two equations we are going to solve them simultaneously for A and what? B. For A and B. We are solving this simultaneously for A and what? We solve them simultaneously for A and B. At this point, we can introduce 4 different methods, or even more than that, of solving. Number 1, you would have known in the secondary school that you will use the method of elimination to solve it. You can use the method of what? Substitution to solve it. You can use the method of, in fact, graphical, the method of graph to solve it. And then we can use another method which we call the determinant method. Are you okay? We have what we call the determinant method. Those are the 4 methods we can use. Any one you like. But I want you to use the method perhaps you would have known already. Even if you have known or you have forgotten, we will use the method of elimination. The method of elimination. My method of elimination, have you written this one? Yes, sir. I shall allow you to wipe it. We're going to use one of the 4 different methods. One of 4 different methods. We're going to use the method of elimination. The method of elimination says, you see this first equation, call this equation A star star. Are you okay? Or you can give it any number you want to give. You call this one B star star. The first equation by what? Sum of x. By x. Let's multiply the sum of, the first equation we want to make sure that one of these is the same thing as the one of these. Is either this one or this one is the same thing. If we multiply this equation here by sum of x, we multiply the first equation by what? sum of x. We'll multiply the second equation by n. Are you okay? Multiply a star star by sum of x. If we multiply a star star by sum of x, what are we going to get? We are going to get a n sum of x plus what? Plus b sum of what? X all squared. We are going to get b sum of squared, or I mean sum of x all squared. And we are going to get equal to what? Sum of x, sum of what? Sum x, sum y. If you multiply, we call it a triple star. If we multiply the second one, multiply beta star by n. We're going to multiply beta star by n. What do we have? We will now have a n sum of what? We will have a n sum of x plus what? Remember, we are multiplying this one by n. We have b n sum of x squared. We will have b n sum x squared equal to what? N sum of x y. This is equal to n sum of x y. This is a triple star. This is equal to check this equation and this other equation. Which of the terms there are equal? Check which of the terms that are equal there. Check this one. A n sum of x and a n sum of x. Are they the same thing? Yes. So we're going to subtract this equation from here. We're going to subtract this equation from here. So what are we going to get? We are going to subtract equations this from subtract equation a star star a triple star from b triple star. Subtract this equation from here. What do we have? We will have, I think this minus this is 0. Yes, sir. Please let's do it. That this minus this is 0. Just like 1 minus 1 is 0. Just like 2 minus 2 is 0. Just like 3 minus 3 is 0. I mean? Yes, sir. This number is the same thing as this one. So this minus this is gone. And we have this. Bn s squared minus 1. So we will have Bn sum of what? S all squared minus the other one. What do we have there? B sum of what? All squared. That's equal to what? What do we have here? We have n sum of x, y. We have what do we have here? N sum of x, y. I mean n sum of x, y. Minus what do we have here? Sum of x, sum of y. Sum x, sum y. Now, if you check the first one here, you will see that there is a D here and there is a B here. Are we okay? Please pay attention. There is a B here, there is a B here. We are going to factorize. We are going to factorize this. We have B into what? N sum of x squared minus 1. Sum of x all squared. Let's factorize. Is equal to what? N sum of x, y minus 1. Sum of x, sum of what? Y. Sum of x, sum of y. To be able to find b hat, we divide the coefficient. We divide this by this. We divide this one by the coefficient. If we want to make a the subject of formula, our answer will now be what? N sum of what? Sum of x, y minus sum of x, sum of what? Y. All over what? N sum of x squared minus sum of x all squared. This is the first parameter of the model called the slope. It becomes n sum of x y minus what? Sum of x, sum of y all over n sum of x squared minus d. The first one is the slope. We are going to look at a certain equation. Equation what? A star star. By equation A star star, we have an is equal to what? We have by equation this, we have an being equal to sum of y minus this, because we are carrying this one to the other side. So it becomes sum of y minus b sum of x. If you want to find a alone, it means you are going to divide it through by what? N. Dividing through by n. What do we have? Dividing through by n. What do we have? If you divide through by n, it means that a will stand alone, Abi? Yes, sir. A will stand alone. And what we have, this, remember, it is now with a cap. A will stand alone, and we have sum of y divided by what? N minus what? B sum of x divided by what? N. That the mean is summation y upon n. Giving what? Y bar minus b summation x upon n is equal what? X bar. So we have this formula representing, we have the formula representing what? The first, what do you call that? The first parameter, representing the intercept. The intercept of a linear model is given as this: y bar minus what? B of x bar. While the slope, which is the second parameter, is given as what? B hat is equal to what? NXD. We'll rush by one small example and then I can end the class. Now let's do it with small example. We have x and y. Let's take that one example. To fit in a linear regression model is to be able to carry the estimates you have gotten and place it in the original linear regression model we have. The original model expectation of y is equal to what? A plus what? Bx. Expectation of y is equal to a plus bx. The error term has expectation 0. Are you okay? The term error has expectation 0. Expectation is also called the mean. The expected value is the mean of that distance. So error has mean 0. But that's the standard deviation. Now to fit a linear regression model, I want us to fit the model a simple is simple linear SLR. I can put M. SLRM, simple linear regression model. Fix the simple linear regression model for that this thing. To fit the linear regression model, we are going to find, here is the formula. There are two formulas that are given us. One of them says we should find, there are two formulas. One of the formulas says A is equal to what? Y bar minus B of X bar. The second one, B hat, says we have n sum of S squared yes. Those are the two formulas that we take into consideration. What do we have in the first? They say we should find the mean of y. I mean, where is y here? Find the mean of y. What does it mean to say find the mean of y? We have to add all the values of y and divide by how many they appear. I mean, so if we begin to add all these values, how many are, what's the value of n? The number of observations. What's the number of observations there in that distribution? 6. In fact, it is 6. You come from 1, 2, 3, 4, 5, and what? 6. There are 6 observations. N is equal to 6. Now we have our n equal to 6. Now, if we have known that y bar can be calculated, s bar can be what? Calculated. S bar can be calculated from x. What about xy? Is xy there in that distribution? Did they give you xy? What? So we're going to introduce xy. What does it mean to say xy? X times y. So someone give us x times y. 5 times 3 will give us what? 15. 5 times 3 is 15. This times this is what? This row. This times this is what? This times this is what? This is what? If you have your calculator there, please confirm. If anyone is not correct there, then you can. Are you okay? Yes, now, but do you own, you can take care of some of x, y. What about, you can take care of some of x because x is there. You can take care of some y is there. What about s squared? Is s squared giving you there? No, sir. So we're going to introduce s squared. S squared means all the values of s you must square them. The square of 5 is what? The square of this is what? The square of this is what? The square of this is what? What about the square of this? Use your calculator to confirm that the answers are like that. If they are not correct, you do what? Adjust them. Now, it means we need to find the totals. Remember what they want is to fit the simple linear regression. SLR means simple linear regression model. So we are going to fit the simple linear regression model. Fit the simple linear regression model. We'll add everything here. If you add this to this to this to this, will give you something like what? Go ahead and calculate it. Go ahead and calculate it. Go ahead and calculate it. Confirms. So what do we have here? 191. 191. 191.
Don't shout. 191.
What about here?
178.
178. 178. I don't have time now that calculate. I mean, now we have, what do you call x bar? I think it's 30 over 5 over 6.
Yes.
So our n is equal to 6. Our x bar is equal to what? 30 over 6, which is 5. Our y bar is equal to what? So y bar is 38 over what? 38 over 5 is equal to what? No calculator. 7.6. 7.6. What about the sum of xy? Sum is what? sum xy is equal to 191. What about sum of x squared? 178. What about sum of x all squared? That means you go to the value of x. Where is the sum? 30 squared what? 900. Is there any sum of y? Yes.
Yes, sir. Yes, sir.
Okay. Sum of y is equal to how many? 88. Sum of x is equal to what? We have all the values here. We can now simply substitute the values into those formulas. Are you okay?
Yes, sir.
We can now substitute the sum of. If we substitute here, you always calculate b first because you put b here. You calculate the slope first before you calculate the intercept. So calculating the slope and the 6, put 6 there. Sum of xy is where is it? 191, I mean?
Yes, sir.
What about sum of x? 10 times sum of y, which is 38. All over the same thing as 6. Sum of x squared is what? What's 78? When you do that, you give me the answer. Let me see. Give me the answer. Let me see. And when you get the answer of b, you will now say a hat is equal to y bar. Where is y bar? You have already 7.6 minus that value you get here times 5. And then you have, so you can now fit another y is equal to, you bring a hat you have calculated there plus what? B hat you have calculated there. The only value that will be here will be this a hat you calculate and this b hat you calculate. So if a hat is 5, we will say y is equal to 5 plus 7x. So the only thing you are going to add is this one and this one. If you do that, then it is as good as fitting the linear regression model. If you have a question on that, I will call it again. Thank you very much for your audience. Thank you very much for your time.